Q9317, which is a definition of V2 speed. A. Takeoff decision speed. B. Takeoff safety speed. C. Minimum takeoff speed. The correct answer is B. V2 speed is a critical parameter in aircraft takeoff performance. It represents the minimum speed that should be attained during the initial climb after takeoff in order to ensure a safe flight path in the event of an engine failure. It is specifically associated with the concept of engine-out safety. In the event of an engine failure during takeoff, V2 speed is the minimum speed at which the aircraft can safely continue the takeoff and climb to a specified height above the takeoff surface. This speed provides sufficient margin to achieve the required climb gradient and obstacle clearance, considering the aircraft's performance capabilities and the prevailing conditions. V1 speed, on the other hand, is the takeoff decision speed, which represents the maximum speed at which the takeoff can be safely aborted if a critical situation arises before reaching V1. V1 is determined based on factors such as runway length, aircraft performance, and safety considerations. In summary, V2 speed is the takeoff safety speed, ensuring the aircraft can safely climb in the event of an engine failure, while V1 speed is the takeoff decision speed, determining whether to abort the takeoff or continue based on critical factors. 9319. What is the correct symbol for minimum unstick speed? A. VMU. B. VMD. C. VFC. The correct answer is A. The symbol for the minimum unstick speed is VMU. VMU represents the minimum speed at which the aircraft can safely lift off or unstick from the runway during the takeoff roll. It is the speed below which the aircraft would not be able to achieve the necessary lift for a safe takeoff. During the takeoff roll, the pilot must ensure that the aircraft reaches or exceeds the VMU speed before rotating or lifting the nose for takeoff. VMU is determined based on factors such as aircraft weight, configuration, runway conditions, and other performance considerations. It ensures that the aircraft has sufficient lift to become airborne and clear any obstacles during the initial climb. VMD and VFC are not the correct symbols for minimum unstick speed. VMD typically represents the maximum descent speed, which is the maximum speed at which an aircraft can safely descend. VFC is not a recognized symbol in the context of minimum unstick speed. 8774. The maximum speed during takeoff that the pilot may abort the takeoff and stop the airplane within the accelerate stop distance is A. V2, B. VREF, C. V1. The correct answer is C. The takeoff decision speed, V1, is the calibrated airspeed on the ground at which the pilot is presumed to have decided whether to continue or abort the takeoff due to engine failure or other factors. 8775. The minimum speed during takeoff, following a failure of the critical engine at V6P, at which the pitot may continue the takeoff and achieve the required height above the takeoff surface within the takeoff distance, is indicated by symbol A. V2 min, B. V1, C. VLF. The correct answer is B. During takeoff, the minimum speed at which the pilot must make a decision to either continue the takeoff or abort it in the event of an engine failure is indicated by the symbol V1. V1 is known as the critical engine failure speed or decision speed. The V1 is a crucial speed that takes into account various factors such as the aircraft's performance, runway length, obstacles, and other operational considerations. It represents the point during takeoff where the pilot must decide whether to continue with the takeoff or abort it, considering the available runway and the aircraft's ability to achieve the required height above the takeoff surface within the available distance. If an engine failure occurs before reaching V1, the takeoff can be safely aborted and the aircraft can be brought to a stop on the runway. However, if the engine failure happens at or after reaching V1, the pilot is committed to continue the takeoff, and the aircraft must be able to achieve the required performance to safely climb and clear any obstacles within the remaining runway distance. V2min and VLOF are not the correct symbols for the minimum speed during takeoff following an engine failure. V2min refers to the minimum takeoff safety speed, while VLOF, liftoff speed, represents the speed at which the aircraft should lift off from the runway during the takeoff roll. 8780. The symbol for the speed at which the critical engine is assumed to fail during takeoff is A. V2, B. V1, C. VF. The correct answer is C. During takeoff, VF represents the engine failure speed. It is the speed at which the critical engine, the engine that, if it fails, would result in the most adverse effect on the aircraft's performance, is assumed to fail. VF is a crucial parameter used in takeoff performance calculations and planning. The critical engine is typically determined based on various factors such as the aircraft's design, engine placement, and other considerations. In multi-engine aircraft, the loss of the critical engine during takeoff is a critical scenario that pilots must be prepared to handle. VF is an important speed for decision-making during the takeoff phase. It is used to determine the point at which the pilot should commit to takeoff, even in the event of an engine failure. If an engine failure occurs below VF, the takeoff can be safely aborted. However, if the engine failure happens at or above VF, the takeoff should continue as planned. It's important to note that VF is distinct from other takeoff speeds such as V1, critical engine failure speed, and VR, rotation speed. V1 represents the decision speed during takeoff, where the pilot must decide whether to continue the takeoff or abort it in the event of an engine failure or other emergencies. VR is the speed at which the pilot initiates rotation to lift the nose of the aircraft for takeoff. In summary, VF is the symbol for the speed at which the critical engine is assumed to fail during takeoff. It plays a crucial role in takeoff performance calculations and assists pilots in making critical decisions during the takeoff phase.